Hello guys, just trying to open the chat here. Just give me a second. There we go. Can everybody see my screen? See my slideshow actually. You just type in the chat.
I can see
everything. Good. Sounds like everybody can hear me and can see everything. That's great. Welcome guys. Welcome to our first RJ Connect Tech Hub webinar training. Today's topic will be we'll be taking a look at Mox's Mgate series and a couple of unique features with our Mgates, and also how Modbus works and so on. So I think there are still a couple of people joining, but I think we can start for now. So welcome guys. I hope you enjoy this webinar, and yeah, just if you have any questions, post them in the chat and we'll try and answer your questions after the webinar. Okay, let's get started. So what we're going to look at today, first we're going to build the foundation for people who don't necessarily have the knowledge of automation systems. We're going to take a quick look at industrial automation system and how all the components fit together. Then we're going to take a look at what is a SCADA, what is a PLC, and then we're going to ask the question, why do we need a gateway? Why are gateways needed? And how we select the gateways that we need. Then we're going to take a look at our MB3000 series and MB4000 series and their features, and also some features of the Mgate 5000 series. Let's start by building the foundation. So with an industrial automation system, you can look at it as a pyramid. In the bottom, we've got our communication layer, where we've got our sensors and devices and IOs and so on. Okay. The next layer, we've got our control level. This is where our SCADA, our DCS systems and PLC systems usually preside. The layer above that, we've got databases, servers for our MES or manufacturing execution systems. And the layer above that, we've got our ERP or enterprise resource planning layer. In between all these layers, we've got a communication layer allowing us communication with the layer below. Okay. A typical system architecture for an industrial control system includes things like a SCADA, our PLCs, and the protocols that we use to communicate with these devices. So on the lower level, you'll see we have our remote IO, UPSs, pumps, drives, and so on. And we communicate with these devices using a specific communication protocol. In some cases, it might be Profibus or Modbus RTU. And then we move to our network layer. And as you can see, this is an Ethernet network. So we typically find communication protocols such as Profinet or Ethernet IP. And these communication protocols allow us to communicate with our SCADA systems. Let's take a look at what a SCADA is. So SCADA stands for Supervisory, Control, and Data Acquisition, which is a system for control, protection, measurement, monitoring, and communication. Now, typically, a SCADA gives you a visual representation of your control system, where we see our actual values and we can control our equipment remotely. So a typical SCADA display would give you a lot of information like our alarms and events, trends for power consumption or temperatures and humidity and pressures and so on. And we've also got the ability to input values to our devices to set certain send points and so on. We also can display temperatures and so on on gauges. Now we get different SCADA brands. I'm sure that many of you are aware of a couple more than we're displaying here, but we typically find Schneider's, InTouch or Wonderware, Droid Systems, Factory Talk, Automation, WinCC, and the new players like Ignition for IoT-based SCADAs. Now, what is a PLC? So a PLC is a programmable logic controller. This is used to control machines and processes. The PLC comprises of a CPU, memory, digital inputs and outputs, as well as analog inputs and outputs. But it also gives us the ability to communicate with our SCADA systems. It runs the PLC program designed with the application needs by using a PLC programming language such as ladder logic, function block diagrams, and STL or structured text language. So here's an example of a machine, and we control this machine using a local HMI and a built-in PLC into the control panel. There might also be some other devices that we communicate with, like our variable speed drives. So this brings us to field bus protocols. Now, currently in the field, we find many different types of field bus protocols. On the left side, or the blue part of the circle, you'll see our serial-based field bus protocols. And on the right-hand side, you'll see our Ethernet-based field bus protocols, such as Ethernet IP, Profinet, and so on. The major players that use some of these protocols are Siemens, that typically uses Profinet or Profibus. However, you do get cards that give the CPU support for Modbus and so on. Schneider, which typically implements Modbus TCP and Modbus RTU, and Rockwell Automation with Allen Bradley's PLCs that use Ethernet IP and DF1. So what is Modbus? Let's take a look at where Modbus started. It was first published by Modicon, but is now part of Schneider Electric. Can you guys still see my screen? Sorry, I had a brief drop there. It's now managed by the Modbus organization, and it's an application layer messaging protocol. Now, what this means is, if you look at the Open Systems Interconnect model, or OSI model, you'll see that we use 7 layers to present or to represent communication. So on the first layer, that would Hi guys, can you hear me? Can you see everything?
Yes, Johan, I can hear now and see.
Okay, great guys. Let me just mute some of the participants. Sorry guys, don't know what happened there. I hope I'm back. Okay, great. Seems like I'm back in the running. All right guys, so let me just go back quickly, one slide. So these are field bus protocols, and the major players use previously used serial-based protocols, but are now able to use Ethernet-based protocols such as Profinet and Ethernet IP, just to give a few examples. So on the next slide, I just want to introduce Modbus, originally published by the Modicon Group, but is now part of, which is now Schneider Electric, but is now managed by the Modbus organization. So it's an application layer messaging protocol. What that means is that if we look at the Open Systems Interconnect model, we see that we've got our 7 layers. Now, an application layer means that it's a layer 7 protocol. Okay, so you'll see on the physical layer, we've got either RS-232 or RS-485, which is typical for serial communications. And then on the Modbus TCP side, we see that it's a physical Ethernet layer. Okay. Now, the only differences between Modbus RTU and Modbus TCP is the fact that we implement a TCP IP header with our standard Modbus layer, making it possible to convert on the fly. And we'll discuss that in a later slide. So what's the difference between Modbus? The difference Modbus variations. So typically with Modbus RTU, the only difference between RTU and ASCII is the amount of serial data bits that we use and the data format. But our topology only allows for one master. So with Modbus TCP, we have the ability to have multiple masters on the same network. Moving from traditional field bus protocols like Modbus RTU, we can see our direct conversion to Modbus TCP from Profinet to, from Profibus to Profinet, and from DF1 or DeviceNet to Ethernet IP. So why then do we need gateways? What purpose does a gateway give us? So if we look at a standard protocol solution, a typical Modbus frame can be used by some SCADA systems using third-party applications or drivers to read the Modbus serial data. But in some cases, we want to convert that serial-based protocol to Ethernet-based protocol. So in this scenario, we use a Modbus RTU frame, and we want to convert it to a Modbus TCP frame. And how we do that is we typically take the Modbus TCP heading and add it to the Modbus RTU frame to make a Modbus TCP frame. This is called a transparent protocol conversion, because we are taking the existing protocol as is, the same format for representing the data, and just representing it or adding a TCP header to that existing representation. But what happens when we need to convert from one protocol to a totally different protocol? This is what's called an agent protocol conversion. So the converted protocols are totally different from one another. The gateway plays 2 roles to communicate with both sides of devices. It is mainly required for connecting serial devices to a SCADA or a PLC. So in this example, we want to convert a Modbus RTU frame or protocol to an Ethernet IP frame. So to be able to do that, we need to be able to make our device or our solution a Modbus RTU master to be able to communicate to our slave. And we need to become an Ethernet IP adapter on the other side so that our SCADA system or PLC can understand. And in this case, we need to physically convert the protocol from one format to another. And this is called agent protocol conversion. Here we take a look at some examples of on-the-fly or transparent communication protocol conversions. So Profibus is a good example to Profinet, DF1 to Ethernet IP, and Modbus RTU to Modbus TCP. If we want to have protocol interoperability, we need to convert from Modbus RTU to Ethernet IP, for example, of Profibus to Modbus TCP, or Modbus RTU to Profibus. These are some examples of agent conversions, and the previous slide were transparent conversions. So, how do we select a gateway? Mox has made it quite simple, but first we need to take a look at who is our master and who is our slave. Now, with a transparent gateway, we typically find that our slave devices just need to communicate with our SCADA. So we need a transparent converter, like an Mgate MB3170, which can have multiple devices on the serial bus, up to 32, according to the Modbus standard. And we can have multiple SCADAs or multiple masters connecting to those same slave devices. In the example where we have an agent gateway, where we need to convert from one specific protocol to another type of protocol, we need an agent gateway. In this example, the Mgate 5105. The Mgate becomes a master on the RTU side, but a slave to the PLC, which is a master. And our SCADA is then a master to the PLC, which is a slave. So we become an agent or a gateway, basically, to convert from Modbus to Ethernet IP. In this example, you can see that our Mgate would be an adapter, and our PLC would be the scanner in Ethernet IP scenario. So Moxa created a quick selection table that we can use. You can take a quick screenshot to grab that this URL, where you will find this Mgate selection table on Mox's website. So if we take a look at, if we want to connect to a Modbus RTU slave, we select device A as a Modbus RTU slave, and our device B is a Modbus TCP client. And if we follow the table, we see Modbus RTU slave, we go all the way down to Modbus TCP client, and then we see that the Mgates that we need to use is an MB3000 series. Another example would be converting from a Profibus master. So our PLC is a Profibus master, and then we'll see we've got a selection of 2 devices there. And we want to convert to Modbus RTU master. So our selection would be an Mgate 4101 or 5111. Another quick example, a Modbus TCP client for device A, and DNP3 serial outstation for device B. And there we'll find the Mgate 5109 as an example. So let's introduce the Mgate MB3000 series. It's part of Mox's Mgate portfolio and converts between Modbus TCP and Modbus RTU. These are our transparent gateways. We've got 3 different models or model series, the 3080, the 3070, and the 3060 for high density and redundancy. Let's take a look at some of the value propositions for these devices. So faster configuration and flexible deployment, reliable and high performance with priority control also, and easier diagnosis and troubleshooting. So we've got 2 methods of configuring our 3000 series gateways. We can either configure them using the Mgate Manager software provided by Moxa, or we can use the built-in web console on these devices. What's nice about the 3000 series is that we have multiple operating modes. We can opt for RTU master to RTU slave conversion, TCP to TCP slave, RTU master to TCP slave, or TCP master to RTU slave. You can see RTU master goes to a TCP slave and vice versa. Another unique feature of the 3000 series is the ability to have Modbus routing. We can route by either using the TCP port that we assign to a specific serial port or a specific IP address. Or we can route by Modbus slave ID table. We also have the ability to do auto-device routing to automatically detect Modbus slaves on each serial port and route according to that routing table. Here's another example of routing by TCP port or routing by IP address. So here you can see the Mgate's IP address 127.10, but we've got several different port numbers for each serial port on the device. So when a request comes in on that IP address on port 2003, the Mgate knows to send the request to that specific serial port on the device. And the same for serial routing by IP address. We can assign different IP addresses in the same range as the Mgate to forward Modbus requests and responses to specific serial ports on the device. Another unique feature for flexible deployment is Ethernet cascading or daisy chaining, where we have scenarios where it's difficult to run separate cables to our PLC system directly. It just makes it easier to connect the devices together in a daisy chain and then back to the network to our DCS or PLC system. Another unique feature of the Mgate 3000 series or 3270 is the serial redirector function. So in a regional system, we'll find that the machine was controlled by an existing serial master, which was an HMI, for example. Traditionally, we had to use a protocol gateway to convert the machine's RTU protocol to TCP, and we could not connect to that machine using the serial master anymore. But with Mox's Mgate MB3270, which has 2 serial ports, we can connect our serial master to the gateway as well as our serial slave device and have the ability to incorporate a SCADA system using Modbus TCP. So there's no need to change the original settings or the original setup for implementing a Modbus TCP network. Let's take a look at some of the unique features in the MB3060 series, such as intelligent mode and agent mode. With agent mode, it's normally used with new built applications where we have a SCADA system incorporating Modbus TCP and Modbus serial devices such as power meters, for example. So we use an internal memory in our Mgate. The Mgate will query the data from the devices directly. So the Mgate is actually the Modbus serial master. And then if any commands from the SCADA come into the Mgate, the Mgate will reply to the SCADA immediately. That makes it fast query time. The only problem with this is it's a complicated configuration, especially when you have a high density Mgate like the 3060 series. Then we've got intelligent mode, where our Modbus request gets sent by the SCADA via the Mgate to the serial device, and the serial device replies through the Mgate to the SCADA system. This makes it very easy to configure, but with large-scale applications, it can make query times a lot longer. So with intelligent mode, the Mgate will learn the Modbus recommand from the SCADA, and it will work as an agent by using those commands that it learned. So it learns the commands from the SCADA system and then actively starts polling the serial devices using those commands. This makes it very easy to configure and shorten the query time in large-scale applications. Another example would be a high-density application where we've got, let's say, up to 128 devices. In transparent mode, our Modbus requests could take up to 8 seconds to complete for all 128 devices. With agent mode, using the tedious process of configuring each Modbus request manually, we get up to 800 milliseconds or so. With intelligent mode, it's about 840 milliseconds for up to 128 devices. So intelligent mode has almost the same performance as agent mode without the complicated configuration. On YouTube, you'll find this unique video from Moxa about explaining the differences in these modes. It's quite a nice video. Go have a look at it. We'll make the links available to you in the chat after the presentation. Another unique feature is priority control, where we can set priority by master or by request format or by specified TCP port, so that we can prioritize which Modbus requests need to be handled first. So our control master has the most or the highest priority, and one of the monitoring stations have a normal priority, and another monitoring station has a lower priority. So with transparent mode, continuing on, we can, this is for diagnosis. So Mox's way with built-in tools for Ethernet and serial troubleshooting, it can be very difficult to troubleshoot serial-based communications when using Modbus RTU. And Mox's gateways make it easier to implement monitoring tools such as the Modbus traffic monitoring tool and TCP exception in the gateway setup itself. We also have the ability to prevent faults by using the fault protection mode to keep the latest data, and serial status monitoring to monitor our serial status. There's another video on Mox's website about this. Please feel free to go have a look at this. And yeah. So Moxa makes Modbus conversion easy as 1, 2, 3. Easy to configure, easy to troubleshoot, and easy to enhance your performance. Another added value is Modbus recently implemented the new industrial Ethernet security standard called IEC 62443, with both account and password management, accessible IP whitelisting, and supports HTTPS and SNMP version 3 protocols. Let's dive into the Mgate 4000 and 5000 series and look at the different protocol conversions that we can implement and some new and exciting features with the 5000 series. So here's an example of the Mgate portfolio from Moxa. We've got a couple of popular industrial Ethernet protocols, such as Ethernet IP, Profinet, Profibus, BMP3, and Modbus, of course. So let's compare the solutions from these different scenarios. Typically, you could buy a PLC module to enable communication to another protocol that is not typically supported by that PLC manufacturer. The pros of this is it's easy to install and it's normally recommended by its vendors. The cons are it's very expensive and can be complicated to configure. We can implement device modules with embedded design. It can be cost-effective for a few devices, but it's difficult to install in some cases, and it's also, with more devices, it can get a little bit more expensive. So using an industrial gateway gives you a high cost-to-performance ratio. It allows you to keep your existing installation even when upgrading your PLC systems. And it has unique and useful features such as serial traffic monitoring to be able to diagnose any issues. The only downside to this is the fact that it's a third-party solution. So typically with a distributed architecture in the past, if you wanted to monitor different machines using a different protocol, you needed to use a separate communication card on your PLC. With the Mgate solution, we can implement an Mgate at each machine or at each station and use the existing bus that PLC uses, simplifying your decentralized architecture. Another distributed architecture for process automation. In the past, we needed to implement a PLC with a card to be able to establish communication with these Modbus devices. But using Mox's Mgate, we can implement a decentralized distributed architecture by keeping your existing infrastructure. So another added benefit of using a device like the Mgate 4101, it's easy to use the device and set up the parameters. The configuration in the, you then configure your gateway PLC and your PLC module for Modbus command IO mapping to Profibus, for example. This could take you about an hour. So if you use the communication card provided by the PLC manufacturer, you need to program that card, and it can take up to 2 hours or longer, making it much better value to use something like a gateway. Another unique or nice feature of the Mgate 5000 series is the built-in wizard in the web GUI, or the web user interface, which takes you from the start to the finish, setting up all your protocols and all your commands that you need to establish communication. Another benefit of using the Mgate is the easy-to-use debug tools to reduce system downtime. So with the Mgate 5105, it takes 2 steps to debug. We open the web console and we start our Modbus traffic monitoring, where we'll be able to check our Modbus communication and check whether our Modbus commands get sent and received to our slave devices. Other tools that are useful is the things such as the SD card, the system log, and email alerts as well. With our quick troubleshooting, we can also use a quick overview of our protocol diagnosis or traffic monitoring. We can look at our protocol diagnosis to see if we've initiated communication with our systems, with our DMP3 master in this case. And we can use the DMP3 serial traffic monitoring to monitor whether we are sending our DMP requests and if we are receiving responses to those requests. Now, a new and exciting feature from the Mgate 5105 Modbus to Ethernet IP converter is the fact that with the upgraded firmware available on Mox's website, we are now able to connect our field devices directly to cloud platforms such as Azure, Alibaba Cloud, or even a generic MQTT broker. Now, what this means is we can pull our devices in the field, Modbus for example, and then publish that data to our cloud platform periodically to be able to do our machine learning applications or database logging or reporting structures using Power BI and so on. So this is a very unique feature from the Mgate series, and we are excited to see applications like this going forward. Just some success case sharing, guys. Here we've got a SCADA application where the need was to collect AC power data from various power meters. And the reason this customer chose to use Moxa is the Ethernet cascading feature, which simplified the installation, fault alarms to identify critical issues quickly, and the protocol analyzer tool to provide protocol analysis to troubleshoot protocol parameter problems. And in this case, they were using the 3270i. Another application was a PLC application where the existing system had a Profibus PLC using Profibus DP, but they needed to communicate with Modbus RTU slaves. So the fan vendor had an upgrade to offer to Modbus RTU integrated, so the end user needs to have a solution for protocol conversion for its existing control system. The benefits for this customer was the high flexibility for design using the decentralized architecture and the Modbus protocol analyzer, and also high cost to performance ratio. Another success case was a power monitoring solution monitoring the UPS and power meters, and they needed to collect these power meter and UPS data information from different serial interfaces remotely. And they also needed a diagnostic tool to identify communication issues. Benefits for this customer was the industrial design and the protocol analyzer tool to troubleshoot quicker. A refrigeration application where they had existing HMI controlling a PLC. They needed the serial redirector function to keep the existing installation working while adding the SCADA system for remote monitoring. Power backup monitoring. The benefits for this customer was multiple TCP connections and also the 2 kilovolt isolation on each serial port. Here's a wash plant example where the plant control system was using Profibus, but the variable speed drive for the coal washing machine was Modbus RTU, and they also needed support for Class 1 ATEX approval for high explosive or explosive environments. An HVAC control and monitoring system where the customer needed to convert from Modbus RTU to Ethernet IP, and they also needed the protocol analyzer tool to provide data view via the web tool, the fault alarm issue to identify critical issues quickly, the SD card for easy replacement, and others support fault configuration when Ethernet is disconnected as well. Power meter reading and quality measurement. This customer needed a total Moxa solution, a user-friendly solution, and also they needed the CCA service from Moxa support. Another typical application, especially in South Africa as well, is a valve control system where the valves is Modbus RTU, but the existing PLC control system is Ethernet IP based. Easy and rapid deployment using web browser setup. Easy to integrate valve actuators on Modbus RTU with Allen Bradley systems, saving rack space and expense, and significant PLC development time savings since the gateway can be mapped as a remote I/O device in the PLC programming software. Okay guys, that brings us more or less to the end of our webinar. Please join us for our next webinar and spread the word of our webinars. Our next webinar will be hosted by one of our FAEs. His name is Frans Magane, and he will be sharing us some unique information about the IOThings, the new IOThings 4510 series. This is a new device. We are very excited to share some information about this device. And remember guys, we are still working, from home. So we are here for you. Stay safe, guys. If you need any information, quotes, accounts, orders, or technical, there's the contact information for those representatives. And we hope to see you in our next webinar. Thank you so very much for joining, and we'll see you in the next one. All the best, guys.